Good morning, everyone. And this is lecture number 13 in circular dynamics. And we are already on the last part of this chapter, both circular dynamics as well as work per energy. In fact, if I say very frankly, we are done with circular dynamics. We have seen what is centripetal acceleration, centripetal force, what is tangential acceleration, tangential force. As such, we are almost done with circular dynamics. But the combination of circular motion or circular dynamics with work, power, and energy, that is where we are right now. And we will try to wind it up in one or two classes as possible. Now let us go back, since we have the ability to go back to the previous class. We were writing equations for what? For motion in a vertical circle. We had chosen 4 points A, B, C, and D. A the lowest one, B on the diameter, C the top one, and D on the left side of the diameter. And we had written some equations, I think some 6 or 7 equations we had written. I think 8 equations we had written till point D. And we were, I think I had given you the task of writing equations for point E and point F. Have you done that? Has anyone written the equations for point E and point F?
Yes, sir.
Okay, so please let me know what is the equation for point E. I think I had written one equation that there is no force in the perpendicular direction. So that equation is already there. Can you tell me the equation number 9, which is the equation in the centripetal direction? Which is the equation in the tangential direction? Sorry, which is the equation in the tangential direction. How much is the force in the tangential direction at point E? Anyone?
G sin theta, sir.
Very good. Mg sine theta. Yes. What I'll do first is I'll just draw the diagram correctly. Diagram is already there. I have just not drawn the forces. No, I have also drawn the forces. I have not resolved the forces in the correct direction. So what I'll do is I will do the first thing. I will resolve the force. So this comes my one force, which is the component of mg in the direction of center
cos
radius.
theta.
That is mg cos theta. Well done, bacha. Then I will draw this component, which is pulling it downwards.
Mg sin
Exactly
theta.
not downwards, at an angle. I know that. That is how much? This
G
component
sin
is
theta.
mg sine theta. Well done, my bacha. Now, what you got to see here, and that we'll also write and note down. Look at what I am going to highlight in green. This mg sine theta ka direction is like this. And this VE ka direction is like this. So your velocity is like this, tangentially, like this. But your mg sine theta is like this. Now, what is this mg sine theta, which is a force, do with this velocity, which is like this? Velocity is like this too. But mg sine theta is like this. What will happen to the velocity if mg sine theta is acting like this? As you can see, they are both in opposite directions. Yes or no?
Yes, sir.
Do you see that in the green that I've highlighted? Do you see it?
Yes, sir.
Velocity is like this. Mg sine theta is like this. So what is this mg sine theta going to do with this velocity? What will this mg sine theta do with the velocity of the particle? Remember, this mg sine theta is the tangential force. So let me write it first. Ft, the tangential force, is mg sine theta. Not two. There are two things about a force. One is the magnitude, other is the direction. I've written the magnitude. Let me write the direction, and I'll just write the direction like this. It is just like going like this in this direction. I cannot write it plus or minus because plus or minus I've taken it upward or downward. It's a vector, so I have to also write this direction. So I write it like this. Mg sin theta is like this. Now, because of this mg sin theta, because of this tangential force, I will have tangential acceleration. Can anyone tell me how much will be the tangential acceleration? 80. Tangential acceleration. How much will be the
G
tangential
sin
acceleration?
theta, sir.
Yes, the tangential acceleration would be equal to g sine theta in the same direction that I have highlighted. We all understand this, right? Now, I've also highlighted something in green. Velocity is like this, force is like this. What is this velocity? What will this force, will do with this velocity? Remember, tangential force, tangential acceleration. This tangential acceleration has one task. Tangential acceleration does one thing. What does tangential acceleration do?
Change the
What?
magnitude, sir.
It changes the magnitude of velocity. Yes, it changes the magnitude of velocity. That means it changes speed. It can either increase speed or it can decrease speed. What it is doing right now, is it increasing speed or is it decreasing speed? Is it increasing speed or is it decreasing speed? This tangential acceleration, what it is doing? Is it decreasing speed or is it increasing speed? No answers?
Decreasing, sir.
Yes, I have an answer here. Yes, Santosh. Yes, everyone in the class. It is decreasing your speed, and remember this. So it is, if I say speed as VE, this VE is going to decrease. In fact, if you look very closely, and again, get you back to the circle, if you look very closely, in the region that I'm going to mark by pink, in the region that I'm going to mark by pin, and here goes the region, dung 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 dung, from A to C, in the region from A to C, in the region from A to C. Can you tell me generally what will happen to the speed of the particle from A to C? I've marked in pink. I've highlighted it in
Decreases,
pink.
sir.
Yes, bacha?
Decreases.
Yes, the speed will decrease. So I write it as V will decrease. So why it is going up from A to C, speed will decrease. Do we understand this? Can I have some raised hand that we understand this? Now, let us look at the other half. I am breaking the circle in two halves. First, I broke it into lower half and upper half. Now I'm breaking it into right half and the left half. What is going to happen in the region that I have marked by
Decreases,
blue?
sir.
Yes?
Decreases.
Yes, the speed will increase. When I go down, I hope the arrow is clear. The speed will increase. Now I ask you, a very simple question. At which point is speed going to be minimum? And at which point the speed is going to be maximum? At which point is the speed going to be minimum? Santosh, and everyone in the online as well as online class. Yes, speed is going to be minimum at point C, and the speed is going to be maximum at point A. Do we understand this? Do we understand this? Can I have some reason that we understand this? Yes, so I will write it here at point A. Speed at point A is maximum, and I will never forget this. It is very simple for you to understand this. I have marked it as yellow. Speed at point A is maximum, and then I move on to point C, and I simply write V at C is minimum. I hope everyone understands this and everyone is noting it down. Speed at
Yes, sir.
point C is minimum, speed at point A is maximum. These are the simple points that you cannot forget. And they come logically. If you understand it, they come logically. Okay, I hope you have noted it down. Let us move our attention to point E, which was the point of concern. We have written the first equation in the tangential direction. Can you now tell me the equation in the radial direction? And we are back with our equations. Can you now tell me the equation number 10, which
TE
is
minus mg cos theta is equal to mve square by L, sir.
that is absolutely correct, bacha. TE towards the center minus mg cos theta away from the center. See this yellow. Mg cos theta is away from the center. TE is towards the center. TE minus mg cos theta, that must be equal to m into VE squared by L. That is the equation that we were looking at. Everyone got this equation? Can I have some raise hand that we got this equation? बहुत अच्छा. Well done. Now only one thing remains, and let us get it out of the system as well. What will be my equation at point F? At point F. Let us move on to point F now. Point F. And I write the equation here, so because I don't have any space and I just can't draw the entire diagram again. So let us move to point F.
mg sin theta, mg sin pi.
First, give me some chance to show my talent as well. So at point F, the force in the perpendicular direction is 0. I never forget to write this so that you understand and remember that we are doing the same thing that we started off with. Okay, the first equation, which I think will be equation number 11. Yes or no? Equation number 11. Give me equation number 11 at point F.
mg sin pi, sir.
Yes, Ft will be equal to mg
Pi.
sine phi. Just I have changed the angle so it becomes phi. Great. Shall I draw the diagram here? I will draw the diagram here with this. Mg is going like this. TF is going like this. I hope everyone sees it. I will color them with green so that everyone. Oops, what has happened? Wrong color. Did not come. I will color them by green. Mg and TF comes like this. Then I will resolve Mg into two components. One component is going to go like this. This component is definitely Mg sine of phi. I hope everyone can see this green component. I know that the figure has become quite cumbersome, but I hope everyone understands this. Then I have mg sine theta. This one is mg sine not theta but phi. Now can you tell me the 12th equation? 12th equation. Can you now tell me 12th equation? 12th equation is the equation at point F in the radial direction. Anyone knows that equation? Please let me know.
TF plus mg sin pi equals to m v square of by L.
Very correct. TF plus mg cos phi, and I'm really running short on space, m vf square by L. I have somehow managed to squeeze it in. Yes, that is the equation that we are looking at. TF plus mg cos phi is equal to mvf square by L. It is as simple as that. Once you get the diagram correct, once you get the concept correct, everything becomes pretty damn simple.
Tangentially from point F is mg cos phi, sir.
Yes, bacha?
From point A, tangential vector is mg sin cos phi.
From point A,
If, sir, from point F you have drawn a tangential, no, sir? It is mg
Okay,
cos
okay.
phi.
Got it, got it, got it, got it, got it. Got it, got it. I'll just correct it. This is what you're saying. I just write it wrongly. This is what you're saying.
Yes, sir.
Okay. Thanks for correcting me out. Okay. Now we have seen what happens to velocity at the lowest point. Velocity speed is maximum. We have understood that. At the highest point, speed is minimum. We have understood that. But I told you there are two things that we must be very concerned about in any question that comes on the vertical circle. There are normally two things that they ask. One is the speed. How much is the speed? What is the other one that I said? And the two are related to each other. One is speed. What is the other one? The first one is speed that we must be concerned about. What is the other quantity that we must be concerned about? The second quantity.
Direction, sir.
Direction, we know, is tangential. The other thing that we must be concerned about, look at all these equations. Look at equation number 2. Look at equation number 4. Look at all the even equations. What did we write in the even equation? We wrote T, we wrote mg, we wrote mv square by L. V is already done. L is known, M is known, G is known. So what is the other thing that we are concerned about? What is the other thing that we are concerned about at all the points? Apart from speed, what is the other thing? What is the other physical quantity that we must know or we must be analyzing it? That is tension in the string, which is making it to move in a circular path. So there are two things. Whatever we do in this question, every time we will be asked any one of those two things. Either we'll be asking or talking about velocity, or we will be talking about tension in this case, or normal reaction in other case. These are the two things that we must be concerned about. Do we get this? Can I have some raise hand that we understand this? Everyone in the class, boys are lifting hands. What about girls? Boys on the right, girls on the left. Okay, great. Now, since we have understood that at point A, velocity or speed is going to be maximum, at point C, velocity or speed is going to be minimum. Now, let us get our concentrations on these two equations which I have marked, which I'm marking in pink. Equation number 2 and equation number 6. These are the two equations I have marked. At point A, we know speed is maximum. At point C, we know speed is minimum. What can you now say about tension at those 2 points? Can you say anything about tensions at those 2 points? At point A, can you say in terms of minimum and maximum? What would be? Obviously, you can find out the value of tension once you know the value of V. What happens to tension as you go from A to C? We have seen that when you go from A to C, pink path speed decreases. As you come from C to A in the blue path, speed increases. Can you say the same thing about tension? What happens to the tension in the string? As you move from A to C, what happens to the tension in the string? And it has got nothing to do with physics, it is simple common sense. What happens to the tension in the string as you move from point A to C in the pink path? Tell me. Equations are also there to assist you. Equations are there to assist you. What happens to the tension as you move from point A to point C in the pink path? Yes, Santosh, you are absolutely bang on. Tension also decreases. So in a way, tension and speed are related to each other very frankly and very straightforward. If V is decreasing, tension also decreases. Yes or no?
Yes, sir.
Now comes the next question. At which point do you think is tension going to be maximum? And no prizes for guessing that one. Which point is tension going to be maximum?
Maximum at A.
Yes, at point
Maximum
A,
at B.
TA will be, or tension at point A will be maximum. I am coloring it in blue. Do we understand this? Tension at point A has to be maximum. Speed is maximum. Tension is also maximum. Then I move my attention to point C. The entire diagram has become very cumbersome, but I hope everyone understands this.
Yes, sir.
Tension at point C. Shall I write it here? Oh, where should I write it? Where should I write it? Where should I write it? This was point B. Where should I write point C? And T at point C. I have somehow squeezed some space. I hope you can see this small thing that I've colored in blue. Tension at point C is minimum. We all understand this? Can I have some raised hands? Now we'll just to confirm it that we will never forget it. Let us write this as important points. Let us write this as important points with a star tag important points. And we shall never forget these important points. Point number 1, from A to C, speed decreases, tension decreases. From C to A, speed increases, tension increases. At lowest point, the lowest point is A, VA and TA are both maximum. At point A, that is why they're writing VA, so that we remember they both have their maximum values. If you know third point, you can guess the fourth point. At highest
Point C.
At highest point, which is C, speed at C and tension at point C, both are going to be minimum. I hope everyone understands this. I will pause for a minute for all of you to note this thing down, and then we shall move ahead. Some important points will be coming. I just can't write all the important points together because I just will go step by step, a minute to win it. You have your minute of glory. Note it down. Okay.
Copy, sir.
I hope everyone has copied it down. We have set of 12 equation, one equation for each point, and we have 6 points that we are looking at. We have not looked at the point on the left hand side. Once you know the points on the right hand side, the points on the left hand side are symmetrical and they are similar. But remember, bacha, what we have written are only the equation of dynamics at all these points. And if you go back to how I told you to solve equations, the first point, the first step was always to draw the diagram and the free body diagram. Second step was to draw all the forces in the 3 direction, tangential, radial, perpendicular. We have done that. But sometimes, most of the times, even writing those equations will not get you the answer. You would have to move on to the next step of solving the problem. Even after writing the force equation, you may not end up with the answer. You may have more unknowns and less equations. Then you will have to move on to the next sets of equation. And what are the next sets of equation that you have to write? Especially in vertical circle. In horizontal circle, you don't need to write it. But in vertical circle, you need to write the next set of equation. What are the next sets of equation? Anyone? That we might have to write, that we will have to write. What are the next sets of equation? Anyone? No one knows it. No, that's not good. What are the next sets of equation? No one knows it. No one knows the next set of equations. Bad. This is bad. No one knows what is the next equation that we are going to write. Disappointed? Very disappointed. Anyways, if you don't remember it, this is the time to remember it. And again, we have come up. Yes, beta?
Lock me or W.
Sorry, I'm not able to hear you out.
Lock me, sir.
Yes, law of conservation of our friend, mechanical energy. We can't forget mechanical energy. 10 most important equation. Let us move. Let us first draw the diagram once again, because the last diagram has become very confusing. Even I can't understand what I'm writing. So I'll just move on. One is the right side equations A, B, C, and then I have the two gentleman points, point E, which is at an angle theta, which I had drawn, and then I have the gentleman point F. You can also call them lady points. Okay. A, B, C, D is there. So let me mark D as well. I may not write the equation, but let it mark so that everything comes in alphabetical order. A, B, C, D, E, F. Let us write the next set of equation, and the next set of equation are the equation for Lockme. Now to write Lockme, we'll have to write potential energies and kinetic energy. So let us draw the speeds as well. Speed at point A is VA. Tangential speed at point E is VE. We're just repeating ourselves, but it's always good to write and draw the diagram so that we are able to understand. And that is why I write the apostrophe, I mean the superscript, subscript, whatever you call it, to understand which point I'm talking about. VA, VB, VC, no VD, VE, and VF. Now, to write the Lockme equations, we must consider some point as our datum or as our zero energy level. Which is the most appropriate point here that I must consider as giving the zero potential energy value? I can take any point in this universe, but which is the most appropriate point here? Which is the most appropriate point here that I must give? That I must give the value of gravitational energy, potential energy as zero. Which is the most important point?
A, sir.
Yes?
A.
Yes, A. I always try to give the lowest point, the gravitational energy zero. So gravitational potential energy of this point is zero. Okay. Now let us write Lockme equation, and let us start from our favorite points. I write Lockme from A to B. Can anyone help me in writing Lockme from A to B? I'll give you 15 seconds to show me your talent. 15 seconds. What is the equation of Lockme from A to B? The countdown has begun. Deepak, Santosh, online, offline kids, bachas, bachis, everyone. What is the Lockme equation from A to B? Everything is right there in front of your eyes. Waiting, waiting, waiting. I'll call that equation, I think 12, equation number 12. Let me call the number as equation number 13.
Half MVA square plus 0 is equal to MGL, sir.
Half mva square, which is the kinetic energy at point A, correct, plus 0. This 0 is?
Potential energy, sir.
That must be equal to, first let us write 0. What is this 0? No, this is not 0. Kinetic energy at point B, it is not 0. How much is that? Half mvb squared plus the potential energy at point B is mgl. Do we all understand equation number 13?
Yes, sir.
I'm not getting some raise hand. Please raise your hands and let me know that we understand this. Equation number 13. Lock me. Girls are not interested in the class today, it seems. No, they are interested. Equation number 13, return from A to B. Now the task becomes more simpler because now I have to write lock me from A to C, and I will write the heading and I will wait for you to give me equation number 14. Lock me from A to C, and I'm waiting for your answers. The clock has already begun. Clock is always running. Time always runs forward. We'll have to catch up with that. Lock me from A to C. Lock me from A to C. Lock me from A to C. Deepak, Santosh, well done, bacha. Give me the equation now. Now is the time that you tell me the equation. Sir, this is the equation. Let's not worry. This is the equation, sir. Lock me from A to C. And what is the lock me equation from A to C? What is the lock me?
Half mv square A equals to mg2l.
No, it is not correct. Half mva square, this is correct, plus 0, which is for potential energy, this is correct. That must be equal to kinetic energy at point C, which you always forget. Yes, Santosh, you are correct. Half mvc square, which is the kinetic energy at point C, plus mg multiplied by 2l. Do we all understand this? Can I have some raise hand that we understand this? Great, 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 great. That takes us to our beach wale 2 points, and let us write the equation for the beach wale point. Let not beach wale point feel lonely. So let us write the log me equation from where to where? From A to E, the neighboring points, A to E. I'm waiting for equation number 15. Countdown is already on. Countdown is already on. Waiting is on. Santosh, Deepak, kids in the class. Log me from A to E. This is what we are looking at. This is what we are looking at. I'll give you a minute to think about equation number 15 and equation number 16. Santosh has given me an answer which is not correct. Log me from half mgl. It's not half mgl. How did you get half mgl? No. You're not thinking correctly. Apply your brains. I'll give you a minute to win it. A minute to show me what you are thinking. I hope everyone has thought about this. Anyone with an answer? Log me from A to E. Santosh is telling me half mva square plus 0. That is correct. mgl sine theta. No. mgl sine theta is not correct. Think. Okay. What I'll do at this point is, see, try to understand, bacha. It's very easier for me. It's very easy for me to write the answers on the board and ask you to copy it down. But that will not serve any purpose. That will only serve the purpose of me finishing your course, you feeling happy about it, that we have understood this. Oh, sir has done it, we understood it. No, if sir does it and you understand it, it's only half of the job done. What is more important is without any sir or any pair, you are able to do it on your own. That is where you must put in that hard work. I can do it in a split second. Why I can do it? Just not because I'm too intelligent or I have great brains. No, my brain is deteriorating day by day. The only reason I can do it or I know it is because I've done it many times. And that is why I know it. And if I have done it many times, you can better it. How many times would I have done this? How many times? I've been teaching for around 18 years. Let us say 18 years. Every year I would have taken 4 or 5 batches for 11th standard. 5 every year multiplied by 18. 90 times I have done it probably. 90 times I have taught it. 90 to 100, somewhere in that range. That is why I know it. Now I need 90 times to write an equation without seeing it. But you don't have that privilege. You can't read it 90 times. But you are better than me. Your brain is better than me. I know that. So if I do something by 90 times, and then I'm able to replicate it, you should be able to do it in 2 times. So if you read it twice, you are 40 times, 45 times more intelligent than me, which you are, every one of you. You have great brains. Your brain is still in the developing stage. Mine has already deteriorated. Way back, way back, way back, way back. 90 times I've done it. That's why I can do it. I can do this. You don't have 90 times to do it. You only have twice. So use your 2 times very judiciously. What I got to do is this point has potential energy 0. Yes, I know this. You don't use your brain that much. I also don't have brain. I don't use it. But since I have done it many times, I just remember it. I just need to find out the value of this h. Now, how difficult it is to get the value of this h? How difficult it is? How will you get the value of this h? This h, the yellow h. How will I get the value of this h? That is the only question here. This h would be this L, which is the total length. L is the total length from A to O. This L minus this much. So the only question now remains is to find the value of this much. This much. And how much is this much? It is simply equal to L cos theta. Now I will not tell you how I got this. You should be able to understand that this is L cos theta. Do we understand that this length is L cos theta?
Yes, sir.
So now you have your answer. Now you have your answer. Can you now tell me what is the Lockme equation from A to E? Can you now tell me what is the Lockme equation from L to E? L to E. L.
MVA square equals to MGL cos theta plus half MVE square.
MVA square. I will not write 0 because I don't have that much space. So I'm letting go of this 0. Half MVA square will be equal to half MVE square plus
MGL cos theta.
MG
L cos theta.
L into 1 minus cos theta. Do we understand this? This side H is L minus L cos theta. So L minus L cos theta is L into 1 minus cos theta. So I have the equation number 15 for Lockme from A to E. And that equation is simply half MA square is equal to half MVE square plus MGL into 1 minus cos theta. This is the yellow equation. Do we all understand this yellow equation? Yes. Equation number 15, getting from the yellow things. Can I have some raise hand if you understand this? Girls. Great. Now is the time, prudent time to write the last equation. Log me from A to F. Which shall be our equation number 16, and again a minute to win it. A minute to win it. Let us see who emerges as the top contender to give me this equation. Again, I have done it 90 times, but you also have done it once now. You have found out the equation from A to E. This is your second time. If you can do it in your second time, well done. Congratulate yourselves. A minute to win it. I hope we'll be back. Now is the time that you tell me what is the log me from A to F. Anyone? No one is trying? It's not that difficult. It's easy.
Half MVA square equals to half
Is equal to
MVF square plus MGL into 2 minus sin phi.
2 minus sin phi. How come 2 minus sin phi? Okay, let us try it. So basically what I got to do is now I have to find out this h, oops, which I am now coloring in my favorite color, pink. I have to find out this h. The task is pretty damn simple. Oh, half MVA square, no problems with this one, plus 0, let us forget the 0, plus is equal to half MVF square. Now how can I find out this h? Two ways, many ways, there could be many ways. There are two ways in which I can find out this h. What is the first way? I like more. I know this L. Oops, now I paint it pink, so pink and yellow becomes orange, I think. Practical application of mixing of colors gives us the second color. Yes, Santosh has come up with an answer. Yes, Pacha, that is correct. So I have L, and I just need to find out the value of this pink. Previously, I got the value of yellow. That was L cos theta. What is the value of this pink? Pink. What is the value of this pink? It is again L cos phi. Do we all understand this? Right angle triangle. One side hypotenuse is L. So this much. This one should be L cos phi. We have done it 200 times. So comes our answer, plus MGL into 1 plus cos phi. And that is the answer. In this format, I like it more. But that doesn't mean that I can't write it in a different way. I could have written it in a different way. How I could have written it? So I now use green. Green. What I got to do now is, let me first do, oops. Let me first do it here. From here to here. Tongue. This is 2L. Someone was saying 2L. From here to here, it is 2L. Green. 2L. From this 2L, if I take out what? This green. So now pink has been overlapped with green. From this 2L, if I take out that green part, the bigger green, I take out the smaller green part, I have my answer again. So I could have written it in a different form. What is a different form? But it does not look symmetric, and that is why I don't use it. Simple reason is that it does not look symmetric, and that is why I don't use it. But that is also correct. I think someone has told me. So this is the same equation written in a different way. Equation number 16, I again call it 16, but I write it in blue. So how I write it now? Half mvs square will be equal to half mvf square, no problems with this one, plus mg into L taken common, 2 minus cos phi. Do we all understand this? The same equation written in a different form. Either you can write it as L into 1 plus cos phi, or you can write it as L into 2 minus cos phi. Do we all understand this? Can I have some raise hand that we understand this? Is it correct? From the green one, I have to take out this one. Have I done it correctly? No, I have not done it correctly. Basically, 2 into L into 2 minus cos phi, I have unknowingly made a very stupid mistake, which someone did it in the first case, and that is why I wanted to describe it. From that green part, bigger green part, I have cut the smaller green part. What I get is not the value of H, the pink one. It's something else. And therefore, whatever I have written in this equation, the blue equation, this is completely wrong, and I should never write it, because I've just overlooked the simple fact that from green, bigger green, if I take out the smaller green, that does not give me the value of this pink part. Do we understand this? What mistake I had made, and what was the mistake in writing it as 2 into 2 minus cos phi? Do we all understand this? Can I have some raise hand now? Correct thing is what I have written in the green one, and this is not correct. And now you know the reason that you have overlooked a simple fact, and this equation is completely wrong. If I overlook a simple fact, we might end up with a completely wrong equation. And remember, bacha, whenever you encounter such a question in JEE Main or Advanced, they will always give you that wrong option. And if you have just overlooked a simple fact in your class, you might just take the wrong answer and go ahead. Do you all understand this? What was the mistake in writing it as 2L minus cos phi? Because I will not get that value. I will get, if I have to say, I will get this part plus this part. That is not the answer, right? I have done it wrongly. Okay, so these are 16 equations that we have written. Now, all of these equations will not be required to make. You will be only concentrating between 2 points, either from A to F, either from A to B, either from A to C, or either from A to E. So maximum, you will be requiring only 4 or 5 equations. From A to B, block में, equations at point A and equations at point B. So those are the main. You'll not be asked to find out everything on the path. I have just told you so that you know how to make equation at any point. If you know that, there cannot be any question that is possible that comes in the exam and you can't do it using these 16 equations. But remember, these are not 16 equations. Please don't be carried away by, oh, sir, 16 equation, how will I do it? No. You only need to make equations of dynamics at the given points. Don't have to make all the equations. I hope you understand. Either you make equations from A to B. So you only make one log from A to B. And then you make equation number 2 and equation number 4, equation number 3, equation number 1, and one log equation, and you are done. Don't require all these equations. So please don't be puzzled. I have written all the equations so that I want to make you understand that if you know how to write one equation, you should be able to write all the equations because they are not different. They are same and similar and come from the same fact. On this note, in the next class, we will be doing some cases. Remember what I said in the first class? What type of motion this body is going to follow? What type of motion this body is going to follow depends on how much speed I give it at the lowest point. So basically, the motion of this body depends on one thing and one thing only. And what is that thing? What is that quantity on which the motion of this entire path depends on? It only depends on one thing. What is that one thing? Don't forget that ever in your life. What is that one thing on which the entire motion depends on? That thing is speed at point A. How much speed I give it at the lowest point, that determines the entire motion. So if you just know the speed at point A, you can tell what is going to happen with the body. And that is what we are going to see in the next class, how speed at point A determines the entire motion of the body. If you know speed at point A, you know absolutely everything about the body, about the motion that you need to know. On that note, I will wind up this class. We'll meet in the next class. I'll try to wind up as soon as possible. Till that time, please go through this. I've done almost everything that was supposed to be done. With all these equations, you should be able to solve any problem that ever comes in this chapter. Take care. Have a nice day. Stay safe, stay healthy, and stay happy. Bye-bye.
Bye, sir.